Hi everyone, welcome back to my channel. In last class we have discussed about filters. So till now we were looking upon diodes and its applications like clipper, clamper, rectifier, voltage multiplier and filters. Next we will be seeing the another diode which is called as Zener diode. So its explanation, it is two layer, one junction, two terminal, bipolar and bidirectional diode. So these four are same as PN diodes, only this differs. So two layer, it has P layer and N layer. It has one junction, P layer, N layer, two layers, and this is one junction, two terminal anode and cathode, anode, cathode, bipolar. That means I have already explained everything in detail in PN diode. Here I'll just explain the overall concept of PN diode for the reverse bias condition. For forward bias. For reverse bias I'll be explaining clearly because Zener diode operates in reverse bias and PN diode will not operate. So I'll explain Zener diode in reverse bias condition how it is operating. So rest all I'll just explain a overall concept. So bipolar I have already told, like current flows from anode to cathode or cathode to anode due to both electrons and holes. Say if any device conducts current or the flow of current is due to either one, like electron or hole. Current will flow because of only electron or only because of holes, then it is known as unipolar. Here the current will flow in the device due to both movement of electrons and holes. So only if there is a movement of electrons and holes both happens, only the current will flow. That's why it is known as bipolar. And bidirectional, the current will flow from anode to cathode and also from cathode to anode. That's why it is known as bidirectional. Anode to cathode and cathode to anode it will flow. So this will flow when it is connected in forward bias condition, and in from cathode to anode the current will flow when it is connected in reverse bias condition. So operation I have already explained. P layer consists of majority of holes, minority of electrons, and N layer will contains maximum number of electrons and minimum number of holes. So because of opposite poles attract each other, they both will move towards each other and they will form or they will recombine at the junction. So the recombination will happen at the junction where electrons and holes will recombine. So now electron and holes are recombined, hence they becomes ions, neutral charge. Both positive and negative charge are combined to form neutral charge. So now because of the speed mismatch, like holes will move faster and electrons will move slower. So because of the speed mismatch, what happens is that the electrons from N layer will get settled at P junction and holes from P layer will get settled at N junction. So now this complete layer is known as depletion layer because of opposite poles attract each other. So plus will move towards minus and minus will move towards plus. That means holes and electrons are moving towards each other and they are combining, they are getting combined at the junction. So they are forming the neutral ion. Because of the speed mismatch, the electrons will get settled at P layer and few holes will get settled at N layer. Now if you see the electrons, holes cannot cross the junction because there are holes here. So like poles are getting repelled. So same way the electrons in N layer can't move or can't cross the junction because there are electrons at P side. So they are getting repelled. So the formation of electrons and hole pair is stopped. Now formation of electrons and holes are stopped. Now what we have to do for the further movement? We have two ways. One is forward bias and another is reverse bias. In forward bias, it will operate same like a PN diode. This is neutral ion along with electrons and holes forming the depletion layer. Okay, so for forward bias, P layer will be connected to positive of the battery and N layer will be connected negative of the battery. So the operation is same, but still I'll just explain on overall. So what happens here, positive, here negative. Here if you see maximum number is holes, that is positive. Here also positive, so like poles repel. Therefore it will move away from the battery and it will try to cross the junction. Again here also it is negative and here also maximum number of electrons is present in N layer. Therefore this minus and this minus, they get repelled, like poles repel. So they will get repelled, so it will not move towards battery, instead it will move away from battery, that is it will try to cross the depletion layer. But this is trying to this electrons and holes are stopping the holes to move from P to N and electrons to move from N to P. So this stopping voltage is known as barrier voltage barrier. For silicon it is 0.7 volt and for germanium it is 0.3 volt. So this barrier potential, or which is known as barrier voltage, is stopping the holes and electrons to move. Now say we are applying this positive voltage. When positive voltage is applied till 0.7, when external voltage is applied till 0.7, no current will flow. So once external voltage becomes greater than that barrier voltage, current starts to flow. So increasing the voltage, increasing V external, current also increases. So if you see, the current direction will be from positive to negative, so the current direction will be P to N. So current flows from anode to cathode. Okay. So this is as same as that, and the graph will be same. So voltage till 0.7, no current will flow. Once 0.7 is reached, current will flow rapidly. That's what forward bias condition. In reverse bias, what happens is that in PN diode, when P layer is connected to negative of the battery and N layer is connected to positive of the battery, what happens is that the like poles repel each other. I'll explain. This is for PN diode. Depletion layer. Okay, so this is connected to negative and this is connected to both. So if you see, the holes are positive, so they get attracted towards the negative of the battery, and here electrons are negative, they get attracted towards positive of the battery. Opposite poles attract each other, so they are getting attracted, and hence they are not crossing the junction. Only when they cross the junction, the recombination takes place and the current flows. But here they are moving away from the depletion layer. Hence what happens is that the depletion layer also will become bigger and bigger, because the electrons are moving this side and holes are moving towards the battery and electrons are moving towards the positive of the battery. So depletion region will become bigger. So what happens when external voltage is increased, it will become difficult for holes and electrons, for minority charge carriers, to cross the junction, because junction is becoming bigger, So okay, so what happens is that the depletion layer will become bigger, the holes will move towards this side, electrons will move towards this side, so only minority charge carriers will be present. Minority charge carriers means negative, positive, this will be present. So what happens, increasing the voltage still more, these minority charge carriers will try to cross the depletion region, and due to that a small amount of current will flow. But still more increasing the voltage, this electrons and holes will obtain a greater velocity and they will move in the faster speed, damaging the depletion layer. So that's why we will not use the PN diode in the reverse bias condition, because it will damage the depletion region. Depletion region will become bigger, so the minority charge carriers will try to cross the depletion region. When voltage is increased in the greater level, it will move in the faster speed and it damages the depletion region. That's why we will not be using PN diode in the reverse bias condition, but here Zener diode we can operate it in the reverse bias condition. I'll explain how. So Zener diode in reverse bias. This is depletion region, this is N layer. So P layer is connected to negative and N layer is connected to negative. So in reverse bias condition, first thing we have to check is depletion layer has to be made thin or narrow. Only because here depletion region actually becomes bigger, it becomes very difficult for them to cross, and increasing the voltage they will move at the faster speed and damaging the depletion region. So if depletion region is made very thin, it will be easier for the electrons and holes to cross the junction and to recombine. Therefore this depletion region is made thin. This is made by using a technique called doping. We already know doping means adding an impurity atom, say like phosphorus or antimony, into pure semiconductor is known as doping. So by using this doping technique we are making this depletion region very thin. So now this depletion region is made very thin. Okay. This is made very thin now. This is connected to negative and positive. Okay. So now let's increase the external voltage. V external. Okay. Here there is no, we will not consider new voltage or barrier voltage. Here we will be considering the Zener voltage. I'll tell that later. So say first we will be connecting negative of the battery. So what happens is that the positive holes will move towards the negative of the battery, and the electrons which is negative will move towards the positive of the battery. So only leftover minority charge carriers will be present here, and leftover minority charge carriers which is holes. Here it is electrons. This is minority charge carrier will be present here. So they will try to move. When external voltage is applied, these minority charge carriers will try to move and small amount of current will flow, that is known as leakage current. Okay. Now increasing the external voltage till Zener voltage. There if we will see for 0.7 and 0.3 which is barrier voltage, here we will be taking the Zener voltage which is maintained constant. So till 0.7 volt the current will flow or current will increase. So once this external voltage becomes greater than the Zener voltage, the current will stabilize and it will remain constant. So now whatever extra voltage you are applying, the current will remain constant. So first, if you see, when you apply an voltage, external voltage, the holes will move towards negative of the battery and electrons will move towards positive of the battery. Only leftover minority charge carriers will be there. They will try to move across the depletion region, and they can move because here depletion region is very thin. So when they move, there will be a recombination, and then small amount of current will flow, that is called as leakage current. Now again, increasing the voltage till Zener voltage, current will flow. This is leakage current, and here the current will also increase. Now when the extra voltage becomes greater than this Zener voltage, the current will not increase, instead it will stabilize and become constant. When this will become constant is that when current reaches maximum, it has to reach maximum and then it will become constant. This current maximum will be determined by the series resistor which is connected in series with the Zener diode. So here if you see, whatever the voltage if you apply, there will be no increase in current, only constant current will flow, hence the depletion region will not get damaged. So whatever the voltage, if you are increasing the voltage step by step also, the current flowing across the diode will remain the same, and hence the depletion region will not break down. So here if you see, the current is from positive to negative is in this direction, so the current will flow from N to P. So current flow is from anode, cathode, so we can write as K to A, cathode to anode. So that's all about Zener diode. This Zener diode mainly used to operate in reverse bias condition, because whatever the external voltage you are applying, the current also increases along with the voltage, but when the voltage meets the Zener voltage condition, the current will stabilize and it will remain constant. For whatever the input voltage you are applying, the current will remain constant. Hence the depletion region will not break, and the current, output current or the output voltage for the varying input, it will remain constant. For this there are many applications like voltage regulator, clipper, same like before. We will see about voltage regulator in the next class.